today we will solve a problem based on where we have to find the total response of a spring plus mass plus damper system, right? So I will sketch the problem, right? So this is the problem, right? So here we have the mass, right? So now this mass is actually subjected to an excitation force of, we'll better call it P cos omega t, because we will first go with the derivation, alright? And here we have the spring, which is having a spring constant of K, right? And we have the damper there, right? Damper, which means something, okay, call it similar to the shock absorber, right? That actually we used to reduce the vibration, right? It actually obstructs that motion, right? So, and also we will say that this is the direction of motion, right? X displacement, let us say downwards, right? So we have the C damping coefficient of the damper, right? And this is the spring constant, right? Fine. Now I'm going to apply the equations of motion, right? The motion equation, right? So now carefully listen, right? How this comes. So now I'm going to say that mx double dot, where x dot is the acceleration, because we know that this axis actually it is a function of time, right? Yeah. So we say that mx double dot, it moves downwards, right? And we are going to equate, we are going to consider the net downward motion, and we are going to equate the forces that are acting in that particular direction as possible, right? Another thing, now we know that if I were to consider this mass, right, this mass is actually pressing both the spring and the damper, right? So if this is the, let's say that this is the state 1, and let's consider this is the state 2, right? So now you can identify that this mass has pressed this mass has actually pressed both the spring and the damper. So let's say now it is like this, right? Because omega t, alright? So now I'm going to break the forces, alright? So then, now if I'm going to break the forces, right, this mass is actually pressing the spring, right? So the force along the spring, right, that means when this mass is actually pressing this particular spring, right, the force, very careful of this term, the force that is exerted on the spring, right, better write that, force that is exerted, on the spring by the mass acts in downward direction. Right? That's what you have to keep in mind, right? So then the reaction on the mass, that will be acting downwards. What is the value? Kx. Similar scenario because of the damp also. So that will be Cx dot, right? And from here we have P cos omega t, which is that excitation force, right? P cos omega t is the excitation force, right? Carefully take these theories, right? Excitation force that acts downwards, right? And because the mass is pressing both the spring and the damper, the reaction of the mass is along upward direction due to the spring and as well as due to the damper. So now I'm going to write the equation of motion. First thing will be P cos omega t. This will be minus k times x minus c times x dot. So now I can make a very nice, beautiful version like this, right? Mx w dot plus, I will first write the derivative terms in order, right? Cx dot plus kx equals P cos omega t, right? I hope that is clear. So now divide by m, right? So okay, so this will be x double dot, right? C divided by m, right? C divided by m, nothing to worry, we can write it as 2 beta omega n, right? Where beta is the damping ratio, right? And omega n is the natural frequency, right? And omega is the natural frequency, right? And I hope that is also clear. X double dot plus 2 beta omega n times x dot plus again is k divided by m. These are special terms. K divided by m, which is square of the natural frequency rate. So that will be omega n whole thing squared x. Here we have P divided by m. So let's do this trick, right? P will introduce spin constant to both upstairs and downstairs, right? So then here we are having m, right? Here we have m, right? Because we have introduced spin constant k to both downstairs and upstairs, right? So P divided by k, this special term, right? We call it static deflection, right? Static deflection, it's not magic, right? K divided by m, we know, right? That is omega n whole thing squared, right? Right. K divided by m is omega n whole thing squared, right? Because we know that omega n equals root k divided by m, right? I hope that is clear, right? So now we can write now here this other part cos omega t, right? That part will continue, right? Because P cos omega t is the excitation force, right? I could have even considered the sign format, but for this problem I'm going to consider P cos omega t. So this cos omega t part will be there, right? Now P divided by k we can replace by this delta, static deflection. This is an omega n square, then cos omega t, right? I hope that part is clear, right? X double dot plus 2 beta omega n x dot plus omega n whole square x, right? Now this is a special case, right? Because now this type of a vibration system, we call it actually forced damped vibration, right? Because we have an excitation force, right? We have that harmonic force, right? So now, if I go to consider the total response, right? X, I will say the total response, right? This total response has two parts. What is the first one? Is the one. Now, this is a differential equation, right? This is a second order differential equation, right? So if you are going to solve that, there will be two parts. One is the homogeneous solution plus the particular integral, right? So the homogeneous solution, or in other words, we can even call it the complementary function, right? Complementary function, right? So this homogeneous solution or the complementary function, that will provide you the transient response, and this particular integral, that will provide you the steady state response, right? So now we know that when solving this type of a differential equation, right, we know that first of all we have to consider the auxiliary equation, right? We have to consider what we call the auxiliary equation, right? Just hold, just wait. We'll focus about this right hand side part, which is actually responsible for the particular integral later, right? First, let's focus this part, right? So now there are several ways of solving this type of equation, right? Or either we can just say let the solution x be whatever constant a to the power s time to. We can either get the approach like that, right? We can even say, let's say the solution to this equation be x equals a to the power st, right? Or we can directly use the d operators, right? So if we use d operators, what we can basically do is now only consider this part, this x double dot plus 2 beta omega n x dot plus omega n squared x equals to 0. Let's consider that part, right? The auxiliary equation, right? So what is x double dot? This is d2x by dt2, right? Because this is an operator, d squared by dt2. This is an operator you cannot separate, right? So now we can write this in this format, d2x divided by dt2, right, plus 2 beta omega n dx by dt. This of course we do not have to worry, omega n squared x equals 0, right? As this is a second derivative, so better denote this d2 by dt to this operator, so better denote this by, let's say, d squared, right? This is a technique, right? Because I'm focusing the d operator method, right? So I can say it as d squared x plus 2 beta omega n dx plus omega n squared x equals 0. So now I can take this x out, right? I can take this x out. So this is the technique, right? So if you take this x out, I can say d squared plus 2 beta omega n d, right, plus omega n squared, right. So now this is a quadratic, right. So this is actually a quadratic, all right. So I can actually go for the general equation. So I'll write it at somewhere in case if you need it as a support. So if you have ax squared plus bx plus c equals to 0, you can say the solution x equals, right, there are two possibilities, that is right, minus b plus or minus b squared minus 4ac over 2a, right. So that technique, if we use here, now here this is a quadratic of d, right. So there are two possibilities, one is d1, other one is d2, right. Minus b, what is minus b? Minus 2 beta omega n, right, minus 2 beta omega n, right? Plus or minus b squared, what is b squared? Minus 2 beta omega n whole thing squared, so that will be 4 beta squared omega n squared, right. B squared minus 4ac minus 4 times a is 1, nothing to worry, this is omega n squared, right, divided by 2 times a, the coefficient is 1, so it will be 2. So if you simplify that, here we have 2 beta omega n plus or minus omega n, we can actually take it out, omega n squared, right, you can just take it out, omega n squared, not even omega n squared, we can even take 4 omega n squared, right. We have to identify the factors, right. See, these are 4 omega n squared, 4 omega n squared, 4 omega n squared, we can take it as a factor, right, times beta squared minus 1 divided by this 2, right. So minus 2 beta omega n plus or minus, because there are two possibilities for the solution, right, 4 omega n squared, if you take the square root of it, that will be 2 omega n, inside the square root we will be obtaining beta squared minus 1 divided by 2, so 2 to 2 you can cancel, so it will be minus beta omega n plus or minus omega n times beta squared minus 1. So what I actually wanted is, so now I need some space actually, alright. So I hope you have taken them, right. So I will erase this part. So this is what actually I want, right, d1 comma d2, that equals omega n times minus beta plus or minus b squared minus 1, right. That is the answer, right, very important, right. d1 comma d2 means there are two possibilities, right. So that equals omega n times minus beta plus or minus beta squared minus 1, right. So now the problem, the area that I want to focus today, right. So now this part also I will erase, right, because I actually need space, right, as this is a special revision session, right. So I don't need this part also, so I will erase that part as well, right. So now here basically I am going to consider the underdamped scenario, right. I am going to consider underdamped case. Underdamped case means where beta is lesser than 1, right. So now according to this case, correct, we know that now it is here this beta is lesser than 1, right, because we are going to focus the underdamped case, right. So that means in this general solution, right, minus beta plus or minus beta squared minus 1, right, as beta is lesser than 1, right, this part definitely will be a negative thing, right. So we can rewrite it in this format, omega n times, right, minus beta. So this part, whatever we have inside, is a negative thing, right? So let's write it in this format, minus 1 times 1 minus beta squared, right? So this is the part that we are going to focus, right? And from the knowledge of complex numbers, we know that I squared equals, right, minus 1, right? So d1 comma d2, that equals omega n times minus beta plus or minus I times square root 1 minus beta squared, right? So now we have two possible solutions, right? What are the two possible solutions that we have? We have d1 equals omega n minus beta, right? Omega n times minus beta plus 1 minus beta squared, one solution. Then we have d2 omega n times minus beta minus, right, 1 minus beta squared. But be very careful. Now here we have that, because now here we have minus 1. So if we take the square root of minus 1, as I squared equals to 1, so the square root of minus 1 will be I, right? So don't forget to include this I component, right? I hope that is clear, right? One, let's break the solution, right? We have plus part and the negative part, but keep in mind this I, right, the unit of that when it comes to the knowledge, as I have explained, right? If I going to take the square root of minus 1, right, so you should get I, right, the imaginary component, right? So now two roots are clear, right? Two roots are very clear now, right? So then now, and here we have another adjustment. It's a damped frequency, so we call it omega d, that equals natural frequency times 1 minus omega squared, right? Right. Because keep in mind, strictly in this problem we are going to focus the underdamped scenario, right? So now what is the solution? X transient, right, or the homogeneous or complementary function, whatever. So that equals, right, let's say whatever constant c1 times e to the power first root of first solution times t, right? c1 sort of a constant times e to the power one particular root e to the power d1 times t plus c2 e to the power the second solution e to the power d2 times t. So now you clearly know what is d1, what is d2. You clearly know about that. I hope this part is clear, right? Now let's write them, right? c1 e to the power, what is d1 now? So that will be, right, I will say omega n times minus beta plus I times 1 minus beta squared times t, right, plus c2 times e to the power d2, the second root, right? What will be that? Omega n times minus beta minus I times 1 minus beta squared times t, right? So what is next? So now we can expand this, right? How can we expand this? c1 e to the power minus beta omega n t. Alright? We can expand this, right? E to the power then I times omega n times 1 minus beta squared times t, alright, plus c2 times e to the power minus omega n beta times t, alright, that time, so I will better put brackets, otherwise you might get confused, right? Then e to the power minus I omega n 1 minus beta squared times t. Alright, now I will close that, right? I hope everything is clear, right? Again, check the values minus beta omega n t minus beta omega n t, right? So the coefficients are clear, right? So now we have expanded that. So next thing is to take the factors, right? Taking the possible factors, right? X, the transient response, and now let's carefully take the factors, right? So that equals here. Now this e to the power minus beta omega n t, we can take it out, right? Now this part, I don't know this part, and here also I don't know this part, right? E to the power minus beta omega n t, we can take it out as a factor, right? So from here that will be c1 times, now look at here, this omega n times square root 1 minus beta squared, this part we can call it as omega d, right? c1 times e to the power, right, I omega dt, right? Because now we have already defined this. Omega d equals the damped frequency equals omega n times 1 minus beta square, right? So that we know. Plus, right? What does matter? I will write this separately again, so that is easy. E to the power minus beta omega n t times that constant will be there, right? Then let's consider for the other part, right? There also we have this part, right? You can take it as a factor, but I will write it separately again, right? Plus, right, e to the power minus beta omega n t, right? Then this constant, that c2 will be there, right? So better write it at the top, right? c2, then e to the power minus I omega d, right? E to the power minus I omega d times t, right? Because this t is a must, right? Now we can take this e to the power minus beta omega n t as a factor, right? So I hope now it is clear. Then put large brackets, right? c1 times e to the power I omega d t, right? Plus from this one also we'll take this e to the power minus beta omega t out. c2 times e to the power minus I omega d t, right? Better to the same time. Alright. Now we are going to refer to the Euler's equation, right? Yeah, we know e to the power I theta is given by cos theta plus I sin theta, right? And in case if it is e to the power minus I theta, then so that is same as e to the power I times minus theta, right? Which equals cos minus theta plus I sin minus theta. Cos minus theta we can write as cos theta. This one can write as minus I sin theta. right? So now we can actually use this expansion, right? All right, we can use that expansion over here, right? So now I again need space, right? Take down your notes, right? Right. Now x transient, that equals e to the power minus beta omega n t, right? Let's consider this one and we'll write the expansion. How can you write that? C1 times e to the power I omega dt. So let's consider this omega dt as a one particular angle, right? So we will be getting what? We need to put another bracket, right? To write the expansion, right? Cos omega dt, cos omega dt plus I sine omega dt, right? Close the brackets. Then the second part, this one, right? C2 times, now we know this part symbolizes actually I times minus omega d times t, right? Now from the basic derivation we know that it should be cos theta, right? Because cos minus theta is cos theta, right? Cos omega dt, it's always better to put the bracket, right? Minus I sine omega dt, right? Right. And I will compute this with the larger bracket, right? Larger bracket symbolizes this one. So I hope the derivations are clear now, right? Again, I need to erase this part, right? Alright, let me erase all these. So if you want, you can pause and refer to the necessary sections, right? So again, I'm still talking about the transient response, right? X transient, that equals, right? So now we can do something like this, right? E to the power minus beta omega n t will be there. Put larger brackets, right? Let's separate these terms, right? Cos omega dt, put the bracket, so that's better, right? Times c1 plus c2, right? Plus, right? I sine omega t, right? I sine omega t, you can take it as a factor, right? It is I sine omega dt, right? The sine part, right? Here I sine omega dt, I sine omega dt, right? Be very careful about putting this terms. So I sine omega dt, right? Times what? So that will be c1 minus c2, right? I hope it is clear now. All right. So the transient solution, right? So the transient solution equals e to the power minus beta omega n times t, right? We'll write the constants at the top, right? C1 plus C2 times cos omega dt, right? Plus I times C1 minus C2 times sine omega dt. All right. Check this one and check this one, right? Now let's consider. Now still we are talking about the transient response e to the power minus beta omega n t, right? So that equals, this will replace with one particular constant, right? So let's call it capital A, cos omega dt, right? So this one, even though we have the imaginary that unit component, we'll consider it as, doesn't matter, another constant b times sine omega dt. I hope everything is clear, right? So this is the transient response, right? No need to worry, right? This transient response part will keep it at here, right? All right. So now I'm going to erase all these, right? Because initially I didn't erase because the reason we need them, right? So now I'm going to keep only the required components, right? Now we have actually derived, right? What is the transient response? What is that? We have derived that e to the power minus beta omega n times t, right? Large brackets a times cos omega dt plus b times sine omega dt, right? Seems like it's not that clear, right? I'll better write it again, right? The transient response, right? X transient, right? Equals e to the power minus beta omega n times t a cos omega dt plus b sine omega dt, right? But be very careful. Please put brackets, that is safe, right? E to the power minus beta omega n t times, if it is not clear, it's because I'm telling everything, right? A sort of a constant cos omega dt plus b sin omega. Why this omega d part comes? This is because understand, we are talking about the underdamped situation, right? So because b is lesser than 1, right? So that is why this omega d comes, right? Sometimes you might get confused from where we got this omega d, right? So I hope now that part is clear, right? Everything clear, right? So you have to practice these things, right? They're not difficult actually, right? Right? I hope that part is clear. Now, what is the problem actually? So our problem is, we have the mass, we have the excitation force. What is the excitation force? P cos omega t and the spring and the damper. So simply this is the problem, right? Because actually we are provided the excitation force as a with a cosine function, right? With cos term, right? Sometimes you can get the problem with sines. It's not a problem, right? Now we need to find the solution. We know that there are two parts, right? When we study that there are two parts. What are the two parts? Two parts are, let's say, x total solution, right? X total solution will be x transient plus x steady state, right? So now this part is clear. Transient part is, that is very clear now, right? So now we have to consider the steady state part, right? That is because of this excitation force, right? Now we have to consider the steady state part. So again I need to write that equation. So now with the memory you can write these things, right? How can you write that? We know that x double dot 2 beta omega n x dot plus omega n squared x, right? So that equals what? That is not it. derived, right? So what is the force that we got? We obtained this one, right? P cos omega t divided by m, right? So that's what we obtained. All right. So now just wait, right? There are certain simplifications that we need to do, right? So I told you to do this trick, right? Right? I told you to do this trick, right? Right. Now, this P divided by K is the static deflection. K divided by M, we know that is omega n squared, right? So this one is cos omega t, right? Which is actually the force, right? Now, this is the method, right? So now we are working on the steady state response based on the particular integral, right? Based on the particular integral, right? The other part of the solution, right? So now x double dot plus 2 beta omega n x dot omega n squared x, right? So now this is what you have. So now we have the excitation force, right? And then we have this response which is x, right? Now we say actually the response lags by phi, or you can say phi, right? The response lags by phi, right? The response lags by an angle of phi with respect to the excitation force, right? The response lags by phi degrees with respect to the excitation force, right? So because of that, carefully focus. So let's say this x equals, alright? So let's say this x equals, alright, some random constant, right? So let's call it, we better call it capital E, right? So let's say, right, this solution x equals, right, E cosine omega t minus 5 as a solution to the particular integral. That is a solution to the particular integral. I hope that is clear. So now what you can basically do here is, right, so now we are just going to say, considering the journey, that we are going to find the other part which is the steady state response. So the particular integral is the one, when it comes to the solid of differential equation, particular integral is the one that is actually responsible for that, right? So then let's say x equals some constant e times cos omega t minus 5 as the solution to the particular integral, right? So now let's take the derivatives one by one. So what is x dot? X dot will be minus e omega sine omega t minus 5. X double dot will be minus e omega squared cos omega t minus 5, right? Differentiate it once, right? Minus e omega sin omega t minus 5. Again differentiate this, right? X double dot, right? That is why x double dot minus e omega squared cos omega t minus 5, right? Now let's put that in this equation, right? So what is x dot? Continue here. What is x dot now? Minus e omega squared, right? Cos omega t minus 5. plus 2 beta omega n. What is x dot? Minus e omega, right, sine omega t minus 5, right? Minus e omega sine omega t minus 5, right? Plus omega n squared times, right, this one x, that's how we have actually defined e cos omega t minus 5, right? Sometimes you might be having a doubt, why have we considered as let x be e cos omega t minus 5, why not plus? Yes, because we consider, because of this arrangement, we say the response lags by an angle phi with respect to the excitation force. That is the logic, that's why we are doing that, right? And this equals, we have static deflection and omega n squared, right, cos omega t, right? Because that is the original excitation force, right? So there is no any phi angle there, right? It is only p cos omega t. All right. Now, next thing, now what you can do is this cos omega t minus 5, you can factorize, right? Cos omega t minus 5, you can factorize. How can we factorize that? If you take it as a factor, from here we have minus e omega squared, right? Minus e omega squared we have from here, right? Then from here we have plus e omega n squared, right? Right, if you consider the factors, right, plus e omega n squared, right? Other part, what is the other part? Is this one, right? Actually there is nothing to factorize there, right? So we have minus sine omega t minus 5, right, minus, let's consider this minus component, minus sine omega t minus 5 times e omega here, because now actually we consider this minus as, let it go there, right? Minus, will subject this part at sine omega t minus 5. What is the balance we have? E omega 2 beta omega n, 2 beta omega n. So this does not look that nice, so we'll arrange it nicely, right? So now we don't need this part, right? So now I can arrange it nicely. All right. Again, this equals, we have to continue that, right? Delta omega n squared cos omega t. All right. Now cos omega t minus 5, e also now we can take it out. What? E also we can take it out, right? Omega n squared minus omega squared. Clear? Then minus sine omega t minus 5. Let's write this one nicely, right? E times 2 beta omega omega n. Now it looks very nice. Equals delta omega n squared cos omega t. Right? Now let's say that this part, right? Let's say that this part we can equate to something like, so let's say f cos alpha. So let's say this part equals f cos alpha, right? Because in order to perform these calculations, we have to do that, right? And let's say this part is something that is similar to f sine alpha, right? Because the thing is, now here we have negative, so our target is to use this formula, as you can remember, cos theta 1 plus theta 2, right? What is cos theta 1 plus theta 2? That is cos theta 1 cos theta 2 minus sin theta 1 sin theta 2, right? Something like that. That is our target, because we want to use this relationship in here, right? Right. I hope that is clear. So that's our target, right? So now we'll proceed. Cos omega t minus 5, right? F cos alpha minus sin omega t minus 5 f sin alpha equals this static reflection times omega n square times cos omega t. I hope that part is clear, right? So now I will erase this part. From here we can take this f out as a factor, right? F we can take as a factor, put large brackets, right? Cos omega t minus alpha cos alpha minus sin omega t minus alpha sin alpha, again sin omega t minus 5, right? Let's go again, right? F times f we can take as a factor, cos omega t minus 5, or you can call it phi, right? That's why I'm telling these terms again. Cos omega t minus 5 times cos alpha minus sin omega t minus 5 sin alpha, right? So that equals delta omega n squared cos omega t, right? I hope that is very, very clear. So this also we will read now. From here we can form, right, f times, right? We can use that the equation, that cosine of the summation of two equations, right? So if you use that relationship here, right, if you consider this one as theta 1, this one as theta 2, right, and this one as theta 1 and this one as theta 2, right, then we can form this equation cosine theta 1 plus theta 2, right? But for the betterment, I will write, that is only for understanding, right? Omega t minus 5, something that is similar to theta 1, right? Plus this alpha, right? That is something similar to theta 2, right? So that equals what? Delta omega n squared cos omega f. We considered it previously, f cos alpha as what? E times omega n squared minus omega squared. You can remember that, right? And also we considered f sin alpha as E times 2 beta omega omega n. You remember we considered that, right? So let's consider this as equation 1 and this as equation 2, right? Previously we considered that during the proof, right? Let's consider f times cos alpha as E times omega n squared minus omega squared, right? And f times sin alpha equals E times 2 beta omega omega n, right? So now let's square the first equation and square the second equation, right? So f squared cos squared alpha plus f squared sin squared alpha equals what? E squared omega n squared minus omega squared whole thing squared plus E squared 2 beta omega n whole thing squared. Alright, and I hope that part is clear. So this part we can take f squared out, famous trigonometric identity, cos squared alpha plus sin squared alpha, right? So this part, what is this part? This part is 1, right? And I hope that is clear, right? Cos squared alpha plus sin squared alpha, that is 1, right? So we can say that f squared equals what? E squared times, right? Omega n squared minus omega squared whole thing squared plus 2 beta omega n whole thing squared. So let's close the bracket by here, right? Because now the problem is we have to find what is this f, right? So now from this equation, right? Now there is a process actually, right? From this simplified version, right? This simplified version of this equation, we can equate the constant term f, and here the constant term is delta omega n squared, right? So we can say that f equals delta omega n whole thing squared. That is from here, right? By just equating the constant term, right? For that particular coefficient over here and here. This is the only constant term here is f, and the only constant term that here is delta omega n squared, right? From here we can form another relationship where this f squared equals e squared times this thing, right? Understand? So from this one, right? Now here this f squared and e squared, these are magnitudes, right? So we are only going to worry about the positive value, right? Otherwise you might be asking, if you are going to take the square root, we have to consider two different values, plus or minus. But here this both f and e, we are going to consider that magnitudes only, right? So we can say, right, here we have f squared equals e squared times this one, omega n squared natural frequency minus omega squared whole thing squared of it, right? This the whole thing squared of it, right? Plus 2 beta omega n whole thing squared, right? So from this one we can say, if you are going to take the square root, that we can say f equals e times square root of what? Omega n squared minus omega squared whole thing squared plus 2 beta omega n whole thing squared. I hope that part is clear. So now we can actually equate these two, right? This tells f equals delta omega n squared. Yeah, this delta is the static deflection. From this one, right? From the formation of this, it produces. So we can equate these two, right? So we don't need these two, so I will erase this, right? Right? Just equate delta omega n squared equals e times omega n squared minus omega squared whole thing squared plus 2 beta omega n whole thing squared, right? So then what is e? What is e now? So e is delta omega n squared divided by square root omega n whole thing squared minus omega squared whole thing squared plus 2 beta omega n whole thing squared. So this is over e, right? And I hope that part is clear, right? Because the reason why I have considered this one, right? Because we started by saying, right? The reason we started by saying, let the steady state solution be, we started by saying let the steady state solution be x steady state equals, right, e times cos omega t minus 5. We started by saying that let the steady state solution be e times E is something like the magnitude, right? E times cos omega t minus 5, right? So that is why we had to do that, right? So now we know what is the value of E, right? Now we know what is the value of E. Right? Next thing, right? Now I hope this part is clear, right? So now we have calculated what is E, right? The simplified version. I will write it here. What is this E now? E equals delta omega n whole thing squared divided by, right, omega n squared minus omega squared whole thing squared plus 2 beta omega n whole thing squared, right? And I hope that is very clear. Alright, so now I will erase this part. Right, now the other thing, now we know what is this value of this magnitude, right? Now what about this angle, right? So now let's consider the cosine angle, right? We can consider this cosine angle, right? Here, now we got to match this magnitude or this coefficient term with this coefficient term, and again we are going to match the angle that we have inside this cos, right? I mean cosine inside what is the angle that we have. So this also has to be same, right? This cosine whatever the angle that you have here and cosine whatever the angle that we have here must be the same, right? So for this to be the same, right, because from this side we have cos omega t minus 5 plus alpha, from this at this side we have only omega t, so only possible way is this part must be 0, right? Understand? Is that clear, right? In order to equate that, minus 5 plus alpha equals 0. So this is a must condition, alright? That is a must condition. So now then, what is 5? 5 is actually alpha, right? But how can you find alpha? Method of finding alpha is that we know that f times cos alpha. F times cos alpha equals what? That is E times omega n squared minus omega squared. Alright. From the previous steps, right? And we know what is f sin alpha. That will be E times 2 beta omega n, right? So let's call this as, let's say equation 1, let's say equation 2. Divide equation 1 by equation 2. So you are getting what? Sin alpha divided by cos alpha, because f to f you can cancel, right? I can write f, but you can cancel that, right? So that equals E times 2 beta omega n divided by E times omega n squared minus omega squared, right? So what you will get? E to E you can cancel. So here sin alpha divided by cos alpha, what you will get? You are getting tan alpha. Tan alpha equals what? 2 beta omega n, very important, right? Divided by omega n whole thing squared minus omega squared, right? So now you know what is alpha, right? Because we considered that the steady state solution to be this phi, right? This one phi, right? We can call it phi. So we know that is alpha. So what is alpha? From here we can say alpha will be, because we considered the solution to be like that, and then this phi to be like that. Then from that we can say, right, fine, okay. So this alpha will be what? From that you can say that will be tan inverse 2 beta omega n divided by omega n squared minus omega squared. I hope now that part is very clear, right? I will write that one here. What is this? This phi equals alpha, where alpha equals tan inverse, right, 2 beta omega n divided by omega n squared minus omega squared. I hope that you are fully okay with it, right? So now from all these steps, right, now we have successfully evaluated what is the steady state, because now we assumed, we considered the steady state solution to be like that, and we know what is E and we know what is alpha. So definitely nothing to worry now, right? Nothing to worry, right? So now we can state the ultimate solution, right? So now we can comfortably say what is the total response, right? We can comfortably say what is the total response. X total response, we can comfortably say that equals X the transient response plus X the steady state response. Right, equals, what is the transient response? That is e to the power minus beta omega n t times a cosine omega dt, better put brackets, plus b times sine omega dt, right? E to the power minus beta omega t times a certain constant times cos omega dt plus b sine omega dt, right? Better remember to put brackets, right? Plus, so that will continue, right? So plus, right? Oh, it's better to write in one line, right? X total, otherwise you get a wrong idea, right? And the other answer, right? What is that? This one. We know what is E plus delta omega n squared, right? Divided by this one square root, right? Omega n squared minus omega squared whole thing squared plus, forgot this one, 2 beta omega n whole thing squared, right? That magnitude part, right? Times cos omega t minus phi, cos omega t minus phi. So this is the answer, right? And also you can mention how you can find this phi, right? So this phi equals what? This phi equals tan inverse, as we have obtained here, 2 beta omega n divided by omega n squared minus omega squared, right? So now, but please remember this is only, be very careful, this is only when beta is lesser than 1, if you are going to consider the underdamped situation, right? So now we know the equation, right? And now we can proceed with a numerical problem.